Okay, so today we're going to be doing direct variation. And you might not know what that word is, but you actually know how to do it. Direct variation is when the relationship is proportional. And as I told you before, a proportional relationship goes through the origin, or b, which is called the y-intercept, is 0. So you have the formula y is equal to mx plus b. And they might use a different formula, but I prefer this one because basically all I'm saying b equals 0. So you're really just focusing on this part. Okay? So it says, which of the equations is not an example of direct variation? Well, A is because it's being added by 1. All right, number 2. So again, it says, which equation is not an example of direct variation? Well, A and C, I know are direct variation because they're not being added by anything. B and D are a little bit different because they're not in the format of y equals mx plus b, which we call slope-intercept form. Come on, pad. So what we're going to do is we're going to take the 2x plus 3y equals 0, and we're going to set it equal to y. So first thing you need to do is you got to get rid of this 2x. That's just a positive 2x, so you subtract it from both sides. This cancels out, and the 3y comes down. Well, 0 minus 2x is just negative 2x. Then you divide 3 to both sides, and you get y is equal to negative 2/3 x. So that is a direct variation. So B is not the correct answer. So D is, I'm going to prove it to you y, because it's good to be able to get into the what y equals. So you have 5x plus 6y equals 30. So I got to get rid of the 5x. So you subtract 5x from both sides. So then these cancel out, and the 6y comes down. Well, 30 minus 5x does not equal 25. That's not how it works. It's basically like it's 30 bananas minus 5 apples. Well, you can't take away from each other because they're not the same kind. So instead, you just do 30 minus 5x. So then that 6 needs to be divided. Well, when you divide it, you have to divide it to everything. So you divide 6 to here, divide 6 here, and then divide 6 here. So this cancels out. Y comes down. 30 divided by 6 is 5. And then 5 divided by 6 is, I'm just going to leave it as 5, 6, x. You can also change this around to have it y is equal to negative 5, 6, x plus 5. So that shows us that's not direct variation. And number 3. So when you have a direct variation, you can find the constant variation, which is also considered your constant rate of change, which is also considered your slope. They all share the constant because it's a proportional relationship. So in 3, the constant of variation is 5. In 4, it's 1/2. And in 5, it's negative 2/3. It's basically what's being multiplied by the x. Okay, suppose y varies directly as x and y equals 16 when x equals 8. You find y when x equals 16. So there's a couple ways I can do this problem. And you have y over x, so that means you have 16 over 8, which equals 2. So my constant is 2, and so my equation would be y is equal to 2x. So it says find y when x is 16, so you just have to plug that into the equation. So you have y is equal to 2 times 16, which equals 32. Or, since you know that they direct vary with each other, you can actually create a proportion. So I have the same thing over here, which is equal to, so since y is on top, the y goes on top over here, and then the 16x goes over here. So then all you have to do is cross multiply and divide, and you would get y is equal to 32 the same way. All right, number 7. So same idea. Y over x, 21 over 3. And I'm just going to set up a proportion to be since y equals 42, so 42 will go on top. If I can write it. Come on. Okay, come on, Ben. 42 over x, so that's what I'm looking for. So you do 42 times 3, which is 126, and then 2 times x, which is just 2x. You divide it, and that's supposed to be a 21. There you go. That makes more sense. So it'd be 21. Divide 21 by both sides, and then that would be 6. Or you could write in the equation where you got y is equal to 7x, and then you plug it in. So you do 42 is equal to 7x, divide by 7, you get 6 equals x. I'm going to skip number 8 and 9 because they're the same idea, and even 10. So number 11 says, does this graph represent a direct variation? It does not, because it does not go through the origin, so no. Okay, 12 is a direct variation because it goes through the origin. So now if it asks you to find the constant, all you have to do is rise over run to find your slope. Hey, word problems. This one word problem is done for you, so you can look through it. I'm actually going to do number 13 and 14 for y'all. So it says a recipe for 2 dozen corn muffins calls for 3 cups of flour. The number of muffins varies directly with the amount of flour you use. So that right here, where it says the number of muffins varies directly with the number of flour you use, is what helps you create your ratio. So you have 2 dozen muffins for every 3 cups of flour. So I'm going to put M for muffins and F for flour. So that means my constant is 2/3. So my equation would be y is equal to 2/3 x. So then it says estimate how much flour you would need for 6 dozen muffins. Well, so you would have 6 down here is equal to 2/3 x. Well, to get rid of this 2/3, you have to do the multiply by the opposite. So you multiply by 3/2, leaving you an x here. So I would multiply 3/2 here, and then you would get 9. So I would need 9 cups of flour. If you didn't want to do it that way, you can still set up a proportion relationship. So you would still have M over your flour, which is 2/3. But you're increasing this muffin size to 6, so it'd be 6 over x. So you cross multiply, you get 18 is equal to 2x. Divide by 2, and you get 9 still. So you need 9 cups of flour. Okay, I guess I did 14 first. Let me go back to 13. Or not. Guess it's not letting me go back up. There we go. Cool. Your distance from lightning varies directly at with the time it takes you to hear thunder. If you hear thunder 10 seconds after you see lightning, you're about 2 miles from the lightning. Write direct variation equation for the relationship between time and distance. Okay, so you're writing between time and distance. And generally, I don't like doing that. It's usually distance versus time. And so I'm actually going to flip-flop those because generally your x is your independent variable, and while your y is dependent, because time is usually x. So I'm going to have distance over time. So it'd be 2 miles for every 10 seconds, which equals 1/5. So my equation would be 1/5 x. So then it would say what would be the time for 4 miles. So you would plug it in. So it'd be 4 is equal to 1/5 x. You divide it. We'll actually be multiplying by 5. So then be 20 equals x. So it'd be 20 seconds. And you'll get the same answer even if it's flip-flopped. You can also set up a formula, a proportion, be 10 over 2. And then the distance is 4 miles over x. So you get 40 is equal to 2x, and you divide 2, and you get 20. So you get the same answer, but generally I like my time to be independent. The distance is dependent upon And I guess not in this scenario, the distance is dependent upon the time, but in a lot of situations, time is x. All right, guys, you really truly know how to do direct variation. It was just a new vocab word that you're learning. Thank you, guys.